A point moves in the xy plane according to the law x equals at, y equals at 1 minus alpha t, where a and alpha are positive constant and t is time. Find the equation of point's trajectory and plot this function, the velocity v and acceleration of the point as function of time, and the moment t at which the velocity forms an angle of pi by 4 with the acceleration vector. So for this particular problem, we are given when the motion along x-axis is equal to x is equal to at, and that along y-axis is equal to at 1 minus alpha t. So from here I can write that t equals x upon a, and if I put this value over here, so we can write it as a x upon a 1 minus alpha t can be written as x upon a. So we obtain the equation of trajectory y is equal to x 1 minus alpha x by a, or we can write it as x minus alpha x square by a. So this is the equation of a parabola. The next we will be calculating about the velocity and acceleration vector. So if we wish to write the velocity and acceleration vector, then along x-axis we differentiate at with respect to time and then obtain the velocity along I cap, and along y-axis we differentiate at 1 minus alpha t with respect to time and obtain velocity along j cap. So from here we write that the velocity vector can be written as a I cap, and along j cap it is written as a1 minus 2 alpha t j cap. Now the next part which is asked is to calculate the value for acceleration. So acceleration can be written as the derivative of velocity with respect to x with respect to dt I cap. This is along x-axis, which will eventually get 0 because it is a constant this time. And along y-axis ay can be written as velocity along y-axis with respect to time t, and we will obtain the value along j cap. So from here we obtain that the acceleration along y-axis we are using w for this symbol. So the acceleration along y-axis is equal to minus 2a alpha. So this is the net answer which we are looking for. This is the velocity vector, and the acceleration vector is only along j cap. There is no I cap term in the acceleration equation. The next the question is asking us to find the time at which the velocity is making an angle of pi by 4 with the acceleration vector. So the angle of pi by 4 with the acceleration vector, so we can again use this concept of dot product, that cos alpha, which is eventually written as cos pi by 4, we are solving for this particular time, v dot acceleration upon magnitude of v, magnitude of acceleration. So on performing the dot product and substituting the values, we obtain cos pi by 4 is equal to 1 by root 2, which is equal to, if we calculate v dot a, this can be written as 2a square alpha 1 minus 2 alpha t upon the magnitude of acceleration in this one. So we write it as a square plus a square 1 minus 2 alpha t square square root dot 4a square alpha square. So from here if we simplify this equation, we obtain t naught is equal to 1 by alpha for this particular problem.